bit simpler way. So first of all, guys, if I have this, I want to get this in quadratic form. So we could find the vertex using transformations, which is perfectly fine. We could also say, well, let's just put this in our vertex form. So this 5 doesn't need to go in front. We can put that in the back. OK? Now, the nice thing I want you guys to notice is when we look at a vertex in vertex form, y equals a times x minus h squared plus k, notice that the vertex, look in that last problem, the vertex is h comma k. So as long as you can identify h comma k, it's like good. It's easy. It's quick. What's the problem with this one? We have another letter in there. Yeah? Has b. And what happens with b? What is b? b. Yeah, but b stinks, right? And what else did you say? b messes everything up. So we can't treat h and k when we have a b. We have to be careful. So let's go back and again recognize b again. Now, that's a nice way of looking at b. But in reality, what we really need to do if we're going to evaluate the vertex is we need to factor out the b. Now, what I told you guys to do was set it equal to 0. And that kind of avoids that factoring out in your brain, which was simple and easy, which is perfectly fine. I'm just going to show you guys how to if I factor out my b in this case, I'll obtain this. Y equals negative x minus 1 squared plus 5. Factoring out a negative is not that bad. Would you guys agree with me? Right? So in this case, now you guys can see there's my b. My b has now been factored out. So I factored my b out of the h2. So it's been factored out. So now I can see that my vertex is just my h and my k. Right? Once I factored out my h and my k, I just kind of have my new points. So my vertex is now 1, 5. OK? But it's very important, guys. A lot of people get this wrong because they immediately look at this and say, oh, it's negative 1, 5. No, 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 no. You have that negative in front of the b. Unless it's shown as being factored out, be careful. b messes everything up. Right? Now, if you don't believe me, let's go and look at Desmos and see if we're correct.